Okay, so looking at the VCAA 2021 Specialist Maths Exam 2 here, we're up to Section B. And we're going to look at the first question on Section B. Now, don't forget these instructions, often overlook the second one here, unless otherwise specified, an exact answer. So if you're giving a decimal answer, it will be specified, or in some other form it will be specified, otherwise exact. So fractions, surds, you need to be given. All right. Diagrams aren't to scale, and G, if we need to use it, is 9.8. All right, first question worth 10 marks, and so we're told let fx equal this expression, 2x minus 3x plus 5x minus 1, x plus 2, and we've got 1 mark to express it in that form there. So this is the calculator job. So go to your calculator, and this is the Casio calculator. If you've got Texas Instruments, you'll need to find out how it's done using that calculator. But for the Casio calculator, what we want to do is we want to turn it into what's a fraction of sorts, and it's called the prop fraction. So we'll go to our action. We're going to transform this, so we're going to change it from the form it's in into something else, and it's a fraction that we're looking for, and it's the prop frac. All right, and so then we can enter our using the down here, so using the templates down there now, and you now enter. Now I think I've already saved that, so if I go and paste, hopefully that goes in. Yeah, so it's paste. So those are not aware, this down the bottom is a copy and a paste. All right, so then just close the bracket on there, prop frac. We want to turn it into a prop frac. There it is. All right, so the form that we're looking for is this one here, a plus, with this bx plus c all over the one thing. So the a is the 2 here, and the bx plus c is the 5x minus 11. So c is negative 11. All right, so you then copy that down to into here. So fx would be 2 plus 5x minus 11 all over x take 1 and x plus 2. All right, so there's our 1 mark for all that. All right, equations of the asymptotes. So that's all asymptotes, not just the vertical ones, but all asymptotes. So vertical and any other, and in this case, the other one's a horizontal one. And the horizontal one is this 2 on the end here. So state the equations of the asymptotes. So y equals 2 is one of the asymptotes. The vertical asymptotes have to do with these factors there. And of course, the bottom can't be then equal to 0, so that can't be equal to 0. So that means that x equals 1 is an asymptote. And over here, the x plus 2 can't equal 0. So that means x equals negative 2 is an asymptote as well. All right, so all 3 asymptotes are needed, and make sure that you give all 3. All right, the next bit is sketch a graph of f on the set of axes, label the asymptotes with their equations, label the maximum turning point, point of inflection with their coordinates, correct at 2 decimal places, label the intersects with their coordinates. Right, there's a whole host of stuff going on there. So again, three marks for all of that stuff. So again, this is a calculated job. So we'll go back to our calculator, and we're going to use our calculator sketch. Now, there's a couple of different ways we can do this. We can actually do it from the main screen, which is where I am, so I'm going to stay there. So what we need to do is tell the calculator what we want it to graph, and we want it to graph y equals all of that stuff there, and all of that stuff there. Remember, I said I'd already saved that. So there we are. I'm going to calculate that, graph that, sorry. Now I need to press EXE, and there it is. All right, to graph it, I need to go up the top here. Here's our graph thing. I need to click on that, and then graph's going to open. There it is, going to open. And what I'm now going to do is copy that expression and drag it down. So on the calculator, let's copy it. There it is, and drag it down. And I've dragged it down, and now it's graphed it. All right, now that looks quite different to what that bit of graph paper is. So what I would suggest is always, whenever you've got scales given, that you change your scale on your calculator to equal the one that's there. So we'll do that with this particular one here, that one there. Where are we? There we are. Click on that, and then so there we are. What do we want? We want the minimum x to be -10. We want the maximum x to be 10. Scale I'm not overly fussed about, but we want our minimum to be -5 and our maximum to be 15. Okay, so that they then match what we've got on being given. All right, so we're going to chop backwards and forwards between that. So first of all, let's go back to our graph paper, and it says sketch the graph, label the asymptotes with their equations. Okay, so remember there was a few asymptotes, and one of them was y equals 2, which is there. Label, it says, so make sure you do label, otherwise you're not going to get all the marks. There was a vertical asymptote at x equals 1. Now you should have a ruler in your possession. Take a ruler in with you. The other asymptote was x equals -2. And there it is. All right. All right, so what else do we want? Label asymptotes with their equations, label the maximum turning point and the point of inflection with their coordinates, correct to 2 decimal places, label the intercepts with their coordinates. All right, so as I said, calculator. Let's go back to our calculator. And so now up the top, we've got our analysis bit here, analysis. What do we want? We want to solve some stuff on the graph. So x-intercepts, let's put them there, what's called roots. All right, so there's one there at -5 and 0. So let me stick my one at -5 and 0. -5 and 0. So remember, it wants this to label it. Is there any others? Well, we use our navigation button and we go across, because there is another one. There it is, 1.5 and 0. So that's here, 1.5 and 0. All right, asks you to label. So remember, we've got a label. All right, so that's all the x-intercepts there are. y-intercept. So again, back to the analysis. G-solve y-intercepts there. And there it is at 0 and 7.5. 6, 7.5. So 0 and 7.5. All right, what else? Maximum turning point and the point of inflection. So let's go back to our calculator. So back to our calculator, our maximum. So again, analysis. Oops, analysis. There we go. Analysis G-solve max. And it's going to look for any maximums. Thinking. There's one there. 4.45 and 2.505. Remember, 2 decimal places is what we were looking at. All right, so 2 decimal places. So 2 decimal places is 4.45 and 2.51. So let's now put that one in on our thing, 4.45, 4.45 and 2.51. That's there, and that's maximum. And our point of inflection, it says. So again, we go to our analysis G-solve, and you'll see the third bottom one there, inflection. And thinking about, is there a point of inflection? There is one, 6.79 and 2.45. All right, so 6.79, so here somewhere, and 2.45, right, just below that other one. All right, so that's 6.79 and 2.45. Probably a good idea if you have in your possession a few different colours so that you can use them rather than all in one colour as I've done. All right, so now let's just fill in the curve. All right, starts this one's in the middle, and then this one here. All right, so let's draw those in. So we've got this side here that comes around through there like so. We've got this one that comes up through here, comes up here, comes there, and comes down like so. And the one in the middle, now let's just check here, because I think the one in the middle, all right, looks like it goes a little bit lower here than the y-intercept. So I'm just going to have a bit of a check, even though we're not asked for it. I'm going to see what that minimum point is. All right, and so it is negative 0.04. It's really, really close. So, and 7.49. So it's really close to it. But so we'll come across here, and we'll go something like that. All right. Okay, so there's everything that we've been asked to do. So just double checking, label the asymptotes, I've labelled them, yes. Label the maximum turning point, yes. Point of inflection, yes. And intercepts with the coordinate axis there, and there. All right, so that's your 3 marks. A lot of stuff there. Make sure you label it, and as I said, it's a calculator job. All right, next part, part D. Now these next 2 parts hardly given us enough space, but anyway, not to worry. So what values so we've now just changed it a little bit. So one of our factors on the denominator, we put this K here instead of what was 1, I think. Was it -1? Yeah, yes, -1. So we've now put a k there, so it could be anything. So it says, what values of k will the graph have two asymptotes? So at the moment, there's three, all right, two vertical and horizontal. So when will there be two asymptotes? Well, if the two factors on the bottom were the same, that would be one situation where there would be two asymptotes, because the one here there would x equals 1 would then shift and be in the same. So one of them is when x minus k equals x plus 2, and so that's k equals 2. There are some others. Now the others will occur if there's some cancelling. So if that cancels, for example, then there would be one. Also, if the x minus k cancelled with the x plus 5, there would also be one. So the other is when x take k is equal to 2x take 3, and that then means that k would be 3/2. All right, so k would be 3/2. Where did I get that? 3 divided by 2. So if k is 3/2, there would be cancelling occurs. And also, as I said, x take k is x plus 5, in which case k would be -5. All right, so there's three values of k where you have two asymptotes. All right, so given the graph of gk has more than two asymptotes, for what values of k will the graph have no stationary points? All right, so first of all, it has more than two. So first of all, we know that k, and I've made a little bit of a blue up here. This shouldn't be x, it should be k, that one. All right, so k equals 3/2. All right, so these three, more than two asymptotes. So k is definitely not those three. All right, so it could be other things. All right, so what we are looking at then is we want it to have no stationary points. So the strategy we can use here is say, okay, when does it have stationary points? All right, so if we find out when it does, then we can exclude those and include everything else. That's the strategy we're going to use. So what we're looking at is g dashed k of x, where that's equal to 0. All right. So we need to get our calculator out and find out what that derivative would be. And so let's get rid of our graph with wrong one. There we go. Get rid of the graph. There we go. All right, so what do we need to do? We need to do this. We need to go, okay, so I want the derivative of, the derivative of, and let's see if that's still in there. That's still in there, but instead of having a 1 here, we've got a k. Now we can use k from the variables, or I'm just going to use z because it's on my keypad. And so the derivative, when we work it out, there it is. All right, and what we want to do is we want to know when is that 0, so we can go solve this up here, drag it down, equals 0, and we want to solve it for x. And so we get the calculator to do some stuff, and thinking. All right, there's a lot of thinking going on here with this particular thing. It looks like it's going to take quite some time to solve that for x, which is a bit annoying, really. Right, I'll have to escape out of that and think about what is it then that we need to look at. All right, and yeah, it still hasn't given me the answer. So, insufficient memory, see? So, all right. So, when you look at that, and we can think, okay, so for this expression to be equal to 0, what are we really looking at? Well, really what we're looking at is this top line here. This part I've just highlighted. When that's equal to 0, that's when this thing's going to equal 0. So let me copy that. And now we'll come down here again and go, okay, so let's solve that equals 0 for x. And then hopefully that's going to work that out a lot better. Now, I should have maybe had that in standard, not decimal. And so let's have a look at what it's going to do. There it is. All right. So what have we got? What we've got is that x is equal to, all right, and you then would transcribe. So we've then got x is equal to negative 4k, and I'm putting the k back in now, negative 4k plus or minus square root 21, and then we've got another square root going on here, minus 2k squared minus 7k plus 15, minus a 15 out on the end, and that's all over 2k plus 3. All right, so you'll get that from your calculator. All right, and so now we need to go, okay, so first of all, what do we know? Well, x is undefined when, so undefined when 2k plus 3 is equal to 0, and so that's k equals negative 3 on 2. And there's no solution when this square root here is less than 0. So no solution when minus 2k squared minus 2k plus 15 is less than 0. All right, and so you can then go and you can then on your calculator graph this minus 2k squared minus 2k plus 15. We go to our calculator and we do that. So let's go to our calculator. Let's graph that stuff. I'm going to do that this time on the graphs and tables. Let's get rid of that one. Oops. Yep. All right, so what am I graphing? -2. I'm going to use z, whoops, that I did before. Z squared minus 2z, except I don't want to use z, because I want to use x, minus 2x squared, because it's an xyx graph, not a yz graph. 2x squared minus 2x plus 15. Let's graph that. And so when we graph that, there we are. We're looking at that there. And so this is less than 0 on these two outer arms. So I need to know where those intercepts are. G-solve roots -3.2. So -3.2, 8 and 2.28. All right. Oh, sorry, I've made a mistake. That's not a 2 there, that's a 7. Sorry, my bad. That there is a 7, not a 2. Yeah, it's 2k squared minus 7k. Sorry, my bad. So let's graph that. All right, that's better. Analysis G-solve roots again. All right, now -5. So when k is less than -5, it's and 1.5, so 3/2. All right, so here we've got k less than -5 and k greater than 3/2. All right. So the question is, when is there no stationary points? Well, there's no stationary points because this expression tells us when we do have stationary points. So we've got no stationary points here when k is less than -5, and here when k is greater than 3/2. All right, and so that essentially will be, oh, and this k here. So no stationary points. When k is less than -5, k is greater than 3/2. All right, I think that's all right. Okay, so that's if k is less than -5 and k is greater than 3/2. You don't need to include this one because the function's undefined then when k is that. So yeah, if the k is -3/2, the function's actually undefined, so that you haven't got a function at all. So there's no stationary points then. Oh well, there's no graph, so you don't need to worry about it. All right, so I'm starting to waffle here. So it's just these two here. So when k is less than -5 and k is greater than 3/2, that's when you have no stationary points.